Go outside on a quiet night, far enough from the city that the streetlights begin to fade behind you. Maybe you are standing in a backyard in the middle of America. Maybe you are beside a dark road, with fields stretching out on both sides. Maybe you are somewhere high and still, where the air feels thin and the sky feels closer than it really is. Above you, the stars seem calm. They do not rush. They do not flicker with urgency. They simply hang there, scattered across the dark, as if the universe has paused for a moment and allowed itself to be seen. And because they look so still, it is easy to believe that you are seeing the sky as it is right now. It feels immediate. It feels present. It feels like the stars are up there in the same moment you are standing here. But that is not what the night sky is. The night sky is not one moment. It is not a single photograph of the universe. It is a gathering of many different times, arriving together in silence. Some of the light above you left its star only a few years ago. Some of it began traveling before you were born. Some of it started moving through space before your grandparents were alive. Some of it crossed the darkness while cities rose, wars ended, forests changed, and entire generations came and went beneath the same sky. And from farther away, beyond the stars you can see with your own eyes, there is light that began its journey before human history had a name. This is the first strange truth about distance in space. When we look outward, we are also looking backward. A star is not simply far away. It is delayed. A galaxy is not simply distant. It is ancient by the time its light arrives. Every point of light is a message that had to survive the dark before it could reach us. And the farther it came from, the older the message becomes. That is why space is more unsettling than it first appears. It is not only wide, it is layered with time. It surrounds us with the past in every direction. Here on Earth, distance usually feels simple. A store may be 10 minutes away. A city may be 3 hours away. A coast-to-coast flight across the United States may take half a day. Even the longest road trip still belongs to a human scale. You can imagine it. You can picture the highway, the gas stations, the changing weather, the sun moving across the windshield. But space does not work on that scale. In space, distance quickly becomes something the human mind was never built to feel. A number can be correct and still be impossible to imagine. A light year can be defined, measured, and written down. But it cannot really be felt in the body the way we feel a mile of walking, or an hour of driving, or a night spent crossing an empty desert road. That is part of the quiet fear hidden in astronomy. The universe gives us numbers we can calculate, but not easily experience. It lets us measure distances that our instincts cannot hold. And so we make the universe smaller in our minds. We draw the solar system on a page. We place the planets close together, like beads on a string. We turn galaxies into glowing spirals on a screen. We look at a deep field image and see tiny smudges of light, forgetting that each smudge may contain hundreds of billions of stars. We compress the universe just to look at it. We shrink it so our thoughts can move through it. But the real universe does not shrink. It remains out there, silent and immense, with distances so large that even light begins to seem slow. Light is the fastest thing in the universe. Nothing carrying information can outrun it. Every image, every signal, every whisper of radiation crossing the cosmos obeys that limit. And yet light still needs time. It needs more than a second to cross the gap from the moon. It needs more than 8 minutes to travel from the sun to Earth. It needs years to reach the nearest stars. It needs thousands of years to cross familiar regions of our own galaxy. It needs millions of years to arrive from the nearest large galaxy beyond the Milky Way. And from the deepest universe, light has been traveling for nearly the entire age of everything we know. So when you look up, you are not looking at a ceiling. You are looking through time. You are seeing old sunlight from distant stars. You are seeing ancient signals that have crossed distances no human body could survive and no human journey could complete. You are standing on a small planet in the present, while the past falls quietly into your eyes. This is where the real journey begins. Not with a spaceship, not with a rocket launch, not with the roar of engines leaving Earth behind. It begins with a simple act that humans have done for as long as humans have existed: looking up. And the longer you look, the stranger that simple act becomes. Because every star asks you to accept a delay. Every distant object asks you to let go of the idea of now. The universe does not show itself all at once. It arrives in pieces. It arrives late. It arrives after crossing darkness so large that the journey itself becomes part of the story. And if the sky above us is made of many different pasts arriving together, then what part of the universe are we actually seeing tonight? Before we travel to the stars, we have to begin with the places that seem close. The moon, the sun, Mars, the familiar names that appear in school books, on calendars, in old mission footage, and in the quiet dreams of anyone who has ever looked up and wondered where we might go next. These are not distant galaxies. They are not strange lights at the edge of the observable universe. They belong to our local sky. They are part of the neighborhood. And yet, even here, distance begins to change the meaning of time. The moon is the closest large world to Earth. On average, it sits about 239,000 miles away. That is a distance a person can understand only because we have crossed it. Apollo astronauts left Earth, coasted through the darkness for about 3 days, entered lunar orbit, and stepped down onto another world. For a brief moment in human history, the moon became reachable. It became footprints in gray dust. It became voices crackling through mission control. It became a place where human beings could stand and look back at Earth hanging in the black. But even the moon is not immediate. Light needs about 1.25 seconds to cross the space between the moon and Earth. That sounds tiny. It is almost nothing compared with the distances waiting farther out. But during the Apollo missions, that delay was real. When an astronaut spoke from the lunar surface, the words did not reach Earth instantly. They traveled across 239,000 miles of empty space before they entered the antennas of the Deep Space Network. And when Mission Control answered, the reply had to cross the same distance again. A conversation with the moon carried a small pause inside it. A silence just long enough to remind everyone that even the closest world was not truly close. That is what near means in space. Not touching, not immediate, only delayed by a little less. Then there is the sun. The sun feels closer than anything. It warms your skin. It fills the morning. It turns the sky blue and makes the world feel awake. It is so present in our lives that we almost never think of it as distant. But sunlight does not arrive the moment it is created. It leaves the surface of the sun and travels about 93 million miles before it reaches Earth. That journey takes about 8 minutes and 20 seconds. The warmth on your face is already old. The daylight outside your window is a message sent more than 8 minutes ago. If the sun could somehow vanish in a single instant, Earth would not know right away. For more than 8 minutes, the sky would remain bright. Birds would still move through the air. clouds would still glow. The oceans would still reflect a star that was no longer there. Then, only after the last sunlight crossed the gap, the truth would arrive. This thought is impossible and unreal because the sun will not simply disappear, but it reveals something true about distance. Even our daylight is delayed. Even the star that makes life possible reaches us from the past. And if the sun, the center of our daily world, is already 8 minutes away by light, then the rest of space begins to feel much less like distance and much more like separation. Now move outward to Mars. Mars has always felt like the next step. Not because it is easy, not because it is safe, but because it is close enough to enter our plans. We have sent orbiters there. We have landed rovers there. We have watched small machines drive across red dust, climb crater rims, drill into rock, and search for signs of ancient water. Mars feels like a world we are slowly learning to touch. But Mars is not waiting at one fixed distance. Earth and Mars both orbit the Sun, and the space between them is always changing. At its closest, Mars can be tens of millions of miles away. At its farthest, when the two planets are on opposite sides of the Sun, the distance can stretch to hundreds of millions of miles. That changing distance changes everything. A signal traveling at light speed can take only a few minutes to reach Mars when the planets are close. But when they are far apart, it can take more than 20 minutes one way. That means there is no real-time conversation with Mars. There is no live steering of a rover, the way someone might steer a drone over a field in Kansas or Arizona. If a rover sees a rock, a ridge, a patch of sand, or a hazard ahead, the people on Earth do not know instantly. The information must first cross millions of miles. Then the answer must cross millions of miles again. Every command becomes a letter. Every response becomes a letter returned. Exploration becomes patient. It becomes planned. It becomes a conversation with silence built into every word. This is why Mars missions are not controlled like vehicles on Earth. Engineers send instructions in batches. They plan the rover's day. They wait. They listen. They receive what Mars has allowed to arrive. And this is still one of our nearest serious destinations. Mars is not across the galaxy. Mars is not another star. Mars is a neighboring planet, a world close enough to appear bright and reddish in our night sky, a world close enough to fill our imagination with future footprints and first habitats. And still, it answers late. From the Moon to the Sun to Mars, the lesson is quiet but unavoidable. Space does not begin with impossibility. It begins with delay. At first, the delay is small. A second, 8 minutes, 20 minutes, then hours, then years, then thousands of years, then millions. The farther we go, the more every journey becomes a waiting room. And this is only the inner part of our own solar system. We have not reached Jupiter. We have not passed Saturn's rings. We have not crossed the dark blue orbit of Neptune. We have not followed the sun's gravity out into the cold shell of comets that may surround us in every direction. We have not even come close to the place where our star's neighborhood truly begins to fade. If even our nearest worlds can only answer after a delay, when does exploration stop feeling like travel and start feeling like sending letters into the dark? Most of us first meet the solar system as a picture. The sun sits on one side, bright and round. The planets line up beside it, each one placed neatly after the next. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. Maybe Pluto is still there too, small and distant, waiting at the edge like the last bead on a string. It is a useful picture. It helps us remember the order. It gives the mind something simple to hold. But it also hides the truth. Because in every school diagram, the planets are drawn far too close together. The solar system looks crowded. It looks organized. It looks almost walkable in imagination. But the real solar system is mostly emptiness. The planets are not sitting close together like marbles on a table. They are tiny islands, separated by oceans of dark space. If Earth were the size of a small marble, the Moon would be another tiny bead several feet away. Mars would not sit just beyond it on the same page. It would be across the room, or across the yard, depending on the scale. Jupiter would be farther still. Saturn would be out beyond the house. Neptune might be down the street, a blue point so far away that the sun itself would begin to feel less like a nearby fire and more like a distant star. That is the part the diagrams cannot easily show. They can show the planets. They cannot show the silence between them. Past Mars, the inner solar system begins to open into the asteroid belt, a broad region of rocky bodies moving around the sun between Mars and Jupiter. The asteroid belt is often imagined as a dangerous field of tumbling rocks packed closely together. But even there, emptiness dominates. A spacecraft can pass through it without weaving through boulders like a scene from a movie. The objects are spread across such enormous distances that most of the belt is empty space. Even a region full of debris is mostly nothing. Then comes Jupiter. Jupiter is immense. More than 1,000 Earths could fit inside it. Its storms are larger than planets. Its magnetic field reaches millions of miles into space. It feels like a world that should dominate its surroundings. And it does. But distance still makes it remote. Depending on where Earth and Jupiter are in their orbits, a signal can take more than half an hour to cross the gap. A command sent from Earth does not reach Jupiter right away. A spacecraft near Jupiter is already operating inside a delay that belongs to another kind of scale. Then comes Saturn, with its rings spread wide and bright. In photographs, Saturn looks almost unreal, as if the universe paused to design something beautiful. But the beauty is far away. A signal from Earth to Saturn can take more than an hour to arrive. Every image returned from that world has already crossed a distance so large that the moment it shows is already gone. The rings are not happening for us now. They are arriving late. Beyond Saturn, the sunlight grows weaker. Uranus moves in a colder region, tipped strangely on its side, rolling around the sun in a way that still feels mysterious. Neptune waits farther out, deep blue and wind-scoured, orbiting nearly 3 billion miles from the sun. At Neptune, the sun is no longer the blazing disk we know from Earth. It is still bright, but it is small. It is distant. It is no longer the whole sky's master in the same way. Voyager 2 reached Neptune in 1989, after about 12 years of travel. 12 years to cross the planetary solar system. 12 years for one brief flyby. No landing. No orbit. No slowing down to stay. Just a passing encounter with a cold blue world. A few hours of priceless data, and then the spacecraft kept going. That was one of the greatest journeys ever made by a machine. And still, it was only a trip through our own neighborhood, because Neptune is not the end. Pluto is not the end either. Beyond Neptune lies the Kuiper Belt, a distant region of icy bodies, dwarf planets, and frozen remnants from the early solar system. This is where Pluto belongs, not as a final border, but as one object among many in a deep outer population. Even here, the solar system does not stop. It becomes thinner. It becomes colder. It fades. Far beyond Pluto, farther than the planets, farther than the Kuiper belt, there may be the Oort cloud, a vast spherical shell of icy bodies surrounding the Sun in every direction. We have never directly seen an Oort cloud object sitting out there in its distant home. They are too small, too dark, too far away, but we see their messengers. Long-period comets arrive from the deep cold, with orbits so stretched and strange that they seem to fall inward from the edge of the Sun's reach. They spend thousands, sometimes millions of years in the dark. Then something nudges them. A passing star, a gravitational disturbance, a small shift in a place almost beyond imagination. And one of these frozen bodies begins a long fall toward the Sun. For most of its life, it is invisible. Then, as it comes closer, sunlight warms its surface. Ice turns to gas. Dust escapes. A tail forms. And for a short time, a traveler from the outer dark becomes visible in our sky. A comet is not just a beautiful object. It is a memory from the edge of the solar system. It is a sign that our home is much larger than the planets. The Oort cloud may stretch outward for more than a light year. That means the Sun's distant gravitational influence may reach a meaningful fraction of the way toward the nearest star. Before we have truly left the solar system, we may already be measuring distance in light years. This is where the word neighborhood begins to lose its comfort, because our solar system is not a tight family of planets. It is a vast, fading sphere of influence. A bright center surrounded by worlds, belts, frozen debris, and an enormous outer silence. We live close to the Sun compared with everything else. We live in the warm inner room. But the house is much larger than we were taught to imagine. Its outer walls are not walls at all. They are a gradual thinning, a long dark boundary where the Sun's pull becomes weaker, and the space between stars begins to take over. And if the Sun's home stretches so far beyond the planets, then where does our neighborhood truly end? There are machines that leave Earth and remain part of Earth forever. Voyager 1 is one of them. It launched in September of 1977, lifted away from this planet on a column of fire, and began a journey that no human being could follow. At first, it was a spacecraft with a mission. It was built to visit the outer planets. It would fly past Jupiter. It would fly past Saturn. It would take photographs, measure fields and particles, listen to the invisible environment around worlds no one had ever seen up close. But over time, Voyager became something else. It became a symbol of departure. A small metal object moving away from the Sun, away from the planets, away from everything that had ever known its name. It became humanity's longest goodbye. Voyager is not large. It is not shaped like the starships of science fiction. It is not sleek or powerful in the way we often imagine deep space machines. It looks fragile, almost handmade, with a dish antenna, long booms, instruments, wiring, and a body built for endurance rather than beauty. And yet it has gone farther than any other spacecraft ever built by human hands. It has crossed the orbit of Jupiter. It has crossed the orbit of Saturn. It has crossed the outer planetary region. It has entered interstellar space, where the direct influence of the solar wind gives way to the thinner, older environment between the stars. No human-made object has ever been farther from home. And still, in the scale of the galaxy, Voyager has barely moved. That is the unsettling part. By human standards, Voyager is fast. It travels tens of thousands of miles per hour. If you could somehow watch it from the side, it would vanish almost instantly from any ordinary human scene. It is faster than any airplane, faster than any bullet, faster than anything that belongs naturally to life on Earth. But space changes the meaning of speed. A speed that feels impossible on Earth becomes almost motionless between the stars. Voyager has been traveling for nearly half a century. For nearly half a century, it has been moving outward every second of every day. Through presidential administrations, through wars, through new generations. Through the rise of personal computers, the internet, smartphones, streaming, and the entire modern world, children have been born, grown old enough to have children of their own, and Voyager has continued outward the whole time. And yet, if the nearest star were the goal, Voyager would still be at the very beginning. The distance to Proxima Centauri is about 25 trillion miles. Even at Voyager's speed, a journey like that would take tens of thousands of years. Not decades, not centuries, tens of thousands of years, longer than recorded history, longer than any nation has lasted, longer than the oldest cities have stood, longer than the entire story we usually call civilization. That means Voyager has not really begun to cross interstellar space in the way our imagination wants it to. It has only stepped beyond the porch light. It has left the warm part of home. The house is behind it now, but the open country ahead is almost endless. And Voyager carries something with it. A golden record. A small archive of Earth. Sounds of wind, waves, thunder, birds, footsteps, heartbeats, music, greetings in many languages, and images that try to explain who we were when we sent it. It is one of the most tender things humanity has ever made. Not because anyone expects it to be found soon. Not because it is a practical message, but because it says something about us. It says that even when the distances are impossible, we still want to introduce ourselves. We still want to say that we were here. We still want the darkness to carry a memory of oceans and voices. In some distant future, long after Voyager can no longer speak to us, the record will still be there. A silent message bolted to a silent spacecraft. The radio signal will fade first. Voyager's power comes from the slow decay of radioactive material. Each year, that power decreases. One instrument shuts down, then another. The spacecraft becomes quieter, less able to sense, less able to report, less able to remain a living part of our scientific world. Eventually, the last signal will come. Maybe it will be expected. Maybe engineers will know the moment is near. Maybe they will listen through the deep space network, waiting for a carrier tone so faint that it is almost indistinguishable from noise. And then, one day, there will be nothing. Not because Voyager has stopped moving. Not because it has reached an end, but because it has gone too far, grown too weak, and entered a silence larger than our receivers can cross. After that, Voyager will continue. No headlines, no new images, no fresh data, no confirmation that it is still there, only motion. It will drift through interstellar space as a small, dark artifact of a planet that once pointed machines toward the sky and let them go. For thousands of years, it will move through the sun's distant outer realm. For tens of thousands of years, it will pass through the cold spaces beyond the planets. In the far future, it may pass within a few light years of another star. But even that is not close in the way we understand closeness. A few light years is still a gulf. A spacecraft can pass a star by cosmic standards and still never enter its warmth. This is what Voyager teaches us. It teaches us that leaving is not the same as arriving. It teaches us that motion is not the same as crossing. It teaches us that a machine can spend ages traveling and still remain near the beginning of the map. And somehow, that does not make Voyager less beautiful. It makes it more beautiful. Because Voyager is not impressive only because of how far it has gone. It is impressive because of how far there is still to go. It is a tiny human-made thing, moving into a darkness that does not care how brave we are. It carries our science. It carries our music. It carries a memory of rain, language, and the sound of a beating heart. And ahead of it, there is not a destination. There is only the long, cold interval between stars. When Voyager finally goes silent, will it still be a message, or only a memory moving through interstellar dark? After Voyager, the mind wants a destination. It wants a point ahead in the darkness. It wants to know what comes next after the sun's influence fades and the solar system becomes only a memory behind us. The answer is a star. The nearest star to the sun, Proxima Centauri. Its name sounds almost comforting. Proxima means nearest. It suggests closeness. It suggests the first stop beyond home. It suggests that if humanity ever begins to cross the space between stars, this faint red point may be where the journey begins. But in space, nearest does not mean near. Proxima Centauri is about 4.24 light-years away. That number looks small. 4.24. It is the kind of number the mind can hold easily. Less than 5. Less than the number of years in a presidential term. Less than the time it takes many children to move from kindergarten to 4th grade. But a light year is not a year. It is distance. It is the distance light travels in one full year, moving at about 186,000 miles per second. In 1 second, light can circle Earth more than 7 times. In 1 year, it crosses nearly 6 trillion miles. And Proxima Centauri is more than 4 of those distances away. About 25 trillion miles. 25 trillion. The number is so large it begins to lose its shape. It is not like driving from New York to Los Angeles. It is not like crossing the Pacific. It is not like flying around the world. Those are human distances. They belong to maps, fuel, weather, highways, airports, and hours spent waiting. Proxima belongs to another scale entirely. At highway speed, you would not arrive. At jet speed, you would not arrive. At the speed of our fastest deep space machines, you would still need a span of time longer than recorded civilization. This is the first wall outside the solar system. Not a wall of rock, not a border guarded by anything. A wall made of distance, a wall made of time. And Proxima itself is not a bright, welcoming star. It is a red dwarf. Small, cool, dim. The most common kind of star in the Milky Way, and one of the easiest to overlook. Even though it is the closest star beyond the sun, you cannot walk outside on a clear American night and point to it with your naked eye. It is too faint. The nearest star is invisible without a telescope. There is something quietly unsettling about that. The closest neighbor in the sky does not shine brightly for us. It hides in plain darkness. Our nearest destination is not a blazing sun calling across the night. It is a small red ember, faint enough to disappear among the black. And yet, around this dim star, there is at least one known planet, Proxima Centauri b. A world slightly more massive than Earth. A world orbiting in the star's habitable zone, where temperatures might allow liquid water under the right conditions. That phrase, habitable zone, sounds hopeful. It makes the imagination open. It lets us picture oceans, clouds, maybe a red sunrise over alien ground. But Proxima b would not be Earth. It orbits extremely close to its star. A full year there lasts only about 11 Earth days. The planet may be tidally locked, with one side always facing the star and the other side held in permanent night. One hemisphere could be trapped in endless red daylight. The other could be frozen beneath a sky that never sees its sun. Between them, there might be a narrow twilight band, a place where day and night meet, a place where temperatures could be less extreme, a place where, if the planet has an atmosphere, winds might carry heat from one side to the other. It is a world that invites wonder, but not comfort. And Proxima Centauri is not gentle. Red dwarfs can flare. They can release bursts of radiation that wash over nearby planets. A planet close enough to receive warmth may also be close enough to receive danger. Any life there, if it exists at all, might need protection. Underground, underwater, beneath ice, behind an atmosphere strong enough to survive the star's long, restless behavior. So the nearest possible world beyond our solar system is not only far away, it may also be harsh, locked, dim, radiation-swept. A place where the word Earth-like would need to be handled carefully. Still, it is there. That is what makes Proxima so powerful in the human imagination. It is not a fantasy. It is not a myth. It is a real star, with a real planet, in the nearest neighboring system. Light from that system reaches us after just over 4 years. If we sent a radio message today, it would take more than 4 years to arrive. If someone there received it and answered immediately, the reply would take more than 4 more years to return. A simple hello and hello back would take more than 8 years. That is not a conversation. That is patience stretched into astronomy. By the time an answer came back, a child would have grown older. A city might have changed. A country might have elected new leaders. A life could have moved into a different season. And this is the nearest star. Not a distant cluster. Not the other side of the Milky Way. Not another galaxy. The nearest one. This is why interstellar distance feels different from any other distance. It does not merely delay travel. It changes the meaning of contact. It makes every message a time capsule. It turns every destination into a future that may no longer belong to the people who began the journey. To reach Proxima in a human lifetime, a spacecraft would need to move at a meaningful fraction of the speed of light, not a little faster than Voyager. Not a better version of the same old rocket. Something radically beyond the speeds we have used for deep space travel. Ideas exist. Tiny laser-pushed sails, fusion concepts, vast engines that still belong more to theory than to mission planning. But every serious idea runs into the same truth. The star is close only in the language of astronomers. For humans, it is almost impossibly far. And maybe that is what Proxima really represents. Not the first easy step into the galaxy, but the first lesson in how difficult the galaxy truly is. It tells us that the stars can be neighbors and still be unreachable. It tells us that a world can orbit the closest sun beyond our own and still belong to a timescale outside ordinary human life. It tells us that the map of the galaxy is filled with points that look close only because the map has been made small enough to fit on a screen. Somewhere out there, Proxima Centauri is burning softly in red light. Its planet is circling quickly, again and again, through short years, beneath a restless star. Its light is already on the way to us. The photons arriving tonight began their journey when the world here on Earth was only a few years younger. And the photons leaving Proxima tonight will not reach us until years from now. The nearest star is not part of our present. It is a nearby past, arriving late. And if the closest star already belongs to a timescale longer than civilization can comfortably imagine, what does the word nearby really mean? After Proxima Centauri, the mind begins to understand that the stars are not arranged for us. They do not sit at convenient distances. They do not form a neighborhood in the way streets form a neighborhood, or towns form a county, or cities form a country. They are islands of fire scattered through a darkness so large that even the nearest one is almost beyond the reach of history. But Proxima is only one star, one faint red dwarf, one point near the sun. To understand the real scale of distance, We have to step back again. We have to let the nearest star become just one light among many. We have to let the sun shrink into its true place. And slowly, around it, the Milky Way begins to appear. Our galaxy is a barred spiral, a vast turning structure of stars, gas, dust, dark matter, and old light. It contains hundreds of billions of stars. Some are small red dwarfs that may burn quietly for trillions of years. Some are bright blue giants that live fast and die young. Some are white dwarfs, cooling remnants of stars that have already finished their long lives. Some are neutron stars, crushed so tightly that a teaspoon of their material would weigh more than a mountain. Some are black holes, invisible except for the way they bend and disturb everything around them. And among all of them, almost lost in the middle distance, is the sun. Not near the center, not at the edge, not special in any obvious way. The sun sits roughly 26,000 light-years from the galactic center, in one of the quieter regions of the Milky Way's disk. It orbits the center of the galaxy at hundreds of thousands of miles per hour. That sounds incredibly fast. But the galaxy is so large that one full orbit takes more than 200 million years, one galactic year, one slow circle around the Milky Way. The last time the sun was in this general part of its orbit, Earth was a completely different world. The continents were arranged differently. The animals were different. The future of mammals had not yet fully opened. No city existed. No language existed. No human had ever looked up and wondered where the stars came from. And still, the sun was moving, still circling, still taking part in a motion so large that a human lifetime is almost too small to notice it. The Milky Way is more than 100,000 light-years across. That means light itself needs more than 100,000 years to cross the galaxy from one side to the other. Not a spacecraft. Not a radio message traveling slowly. Light. The fastest thing the universe allows. A beam of light leaving one edge of the Milky Way would cross the galaxy through ages of planetary change. On Earth, ice sheets could advance and retreat. Species could rise and vanish. Civilizations could be born, forget themselves, and become ruins before that beam reached the other side. At this scale, distance stops feeling like distance. It becomes deep time. It becomes history stretched into space. It becomes the reason a galaxy can be full of stars and still feel silent. This is the part that changes the way we think about other life. The Milky Way may contain hundreds of billions of planets. Many of them may be rocky. Some may orbit in zones where liquid water could exist. Some may have atmospheres. Some may have oceans. Some may have clouds moving over continents we will never see. And perhaps, somewhere among them, life has appeared. Perhaps more than once. Perhaps many times. But a galaxy can be rich with worlds and still be divided by distance. If a civilization lived 1,000 light-years away, its light would take 1,000 years to reach us. A message from them would arrive as an artifact from their past. A reply from us would take another 1,000 years to return. One question and one answer would require 2,000 years. That is not a conversation in any human sense. That is not two minds speaking. That is archaeology with a pulse. It is one civilization sending a thought into the dark and hoping that something still exists when the answer comes back. And 1,000 light-years is not even a large distance inside the Milky Way. It is only a small patch of the galaxy. There are stars 10,000 light-years away. There are stars forming regions farther than that. There are globular clusters, ancient swarms of stars, orbiting the galaxy like old memories. There is the galactic center, hidden behind dust, 26,000 light-years from us. A signal sent there from Earth would arrive after 26,000 years. A reply would return after another 26,000. A single exchange would take 52,000 years. That is longer than recorded human history many times over. Longer than agriculture. Longer than cities. Longer than every empire, every border, every written word. The Milky Way may be our home galaxy, but most of it cannot become part of our present. It can only become part of our waiting. Near the center of the galaxy, the stars are packed more tightly. There are regions where the night sky would be brilliant with nearby suns. A planet there might have a sky so crowded that darkness would never feel the way it feels on Earth. But near the center, there is also danger. Radiation. Crowded orbits, exploding stars, great clouds of gas and dust. And at the heart of everything, Sagittarius A star, the supermassive black hole at the center of the Milky Way. It has about 4 million times the mass of the Sun. It does not swallow the whole galaxy. It does not pull us in like a drain. It simply sits at the center of the gravitational dance, surrounded by stars moving at astonishing speeds. We have imaged its shadow. And we have watched stars whip around it. We have measured its presence by the motions of things we can see. But the light from that region takes 26,000 years to reach us. The center of our own galaxy is not shown to us as it is now. It is shown to us as it was when human beings were still living in the deep past of Earth. When we study the Milky Way, we are studying our home through delay. Even home is not immediate. Even home arrives late. And this makes the galaxy feel different. Not like a city, not like a country, not like a place where one part can call another and expect an answer. The Milky Way is more like a dark ocean, filled with lighthouses. Each lighthouse shines. Each one may have worlds. Each one may have stories. But the light moves slowly across the ocean, so slowly that one shore may never know what is happening on the other. This may be one reason the galaxy feels silent. Not because nothing is there. Not because no one has ever looked up from another world. Not because intelligence could not exist elsewhere. But because distance makes every voice faint. Distance makes every answer late. Distance turns even light into a slow messenger. We have only been listening seriously for a short time. Only a few decades. Our own radio signals have reached only a small bubble around Earth. A tiny sphere compared with the size of the Milky Way. Most of the galaxy has never heard us. Most of the galaxy has not had time to hear us. And if someone far away sent a signal long ago, it may still be crossing the dark. It may not have arrived yet. It may arrive thousands of years from now, when no one alive today is here to receive it. This is the quiet loneliness of a galaxy. Not emptiness, not absence, but separation. The possibility that many worlds may exist, each under its own sky, each wondering, each listening, each waiting inside a silence created not by choice, but by scale. The Milky Way is beautiful because it is full. It is frightening because fullness does not guarantee contact. A galaxy can hold hundreds of billions of stars and still keep them apart. It can be crowded with suns and quiet with distance. It can be our home and still be too large for conversation. And if the Milky Way is filled with planets, but every possible greeting takes centuries or millennia to return, is the galaxy crowded or only quietly alone? After the Milky Way, the mind needs another step back. It needs to leave the galaxy without really leaving it. It needs to imagine our home not as the whole sky, but as one island of stars among many. From Earth, the Milky Way can feel endless. It crosses the night like a pale river, a soft band of light, made from billions of suns too distant and crowded for the eye to separate. For most of human history, that river may have seemed like the largest structure there was, a great shining path overhead. A ceiling of stars. A home so wide that nothing beyond it could be easily imagined. But the Milky Way is not alone. Beyond its spiral arms, beyond its halo of old stars, beyond its dark matter, beyond the small satellite galaxies orbiting around it, there are other galaxies. And one of them is close enough to be seen without a telescope. Andromeda. Under a dark sky, far from city lights, Andromeda appears as a faint, stretched glow. Not sharp, not dramatic, not the grand spiral you see in telescope images. To the naked eye, it looks like a soft smudge in the dark, a pale oval, a little cloud that does not move with the weather. It is quiet enough to miss. You could stand beneath it and never notice it. You could look straight toward one of the largest galaxies near us and see only a faint blur. But that blur is not a cloud. It is not part of our atmosphere. It is not a nearby star cluster. It is a galaxy. A vast spiral system, with perhaps 1 trillion stars. It has dust lanes, star-forming regions, old stellar populations, young blue stars, globular clusters, satellite galaxies of its own. And at its center, a supermassive black hole, far more massive than the one at the heart of the Milky Way. All of that is hidden inside the faint glow that a human eye can barely hold. Andromeda is about 2.5 million light-years away. That means the light reaching your eyes tonight began its journey about 2.5 million years ago. Not 2.5 million miles, not 2.5 million days, 2.5 million years. When those photons left Andromeda, modern cities did not exist. Writing did not exist. Farming did not exist. The United States did not exist. No country you know had a name. Human beings as we know them were not yet walking through history. Earth belonged to older ancestors, older landscapes, older animals, older climates. And through all of that, the light from Andromeda kept traveling. It crossed intergalactic space while ice ages came and went. It crossed the dark while early humans learned to use tools, fire, language, and memory. It crossed the dark while species changed, continents shifted, rivers carved valleys, and the night sky over Earth was watched by eyes that were not yet ours. Only now has that light arrived. Only now does it enter the eye. Only now do we call it Andromeda. But what we see is not Andromeda now. It is Andromeda as it was 2.5 million years ago. Its present is still out there. Its present has not reached us. Some stars we see in Andromeda may have already died. Other stars may have formed after the light we see tonight had already left. Nebulae may have changed shape. Clusters may have drifted. Worlds may have been born. Worlds may have ended. But those changes are still traveling. Their light is still crossing the distance. They are not part of our sky yet. This is the strange thing about seeing another galaxy. It feels like contact. It feels like proof. It feels like the universe has allowed us to look directly at something real. And it has. But sight is not the same as presence. The light is here. The galaxy is not. Andromeda is a neighbor only in the language of cosmology. By human standards, it is impossibly far. If the Milky Way is more than 100,000 light-years wide, the space between us and Andromeda is about 25 times the width of our entire galaxy. Imagine crossing the Milky Way once at the speed of light, then doing it again, and again, and again, 25 times. Only then would you reach the distance between these two neighboring galaxies. This is what close means outside the Milky Way. It means millions of years for light. It means a galaxy visible to the naked eye and still beyond any journey we can seriously imagine. And yet Andromeda is moving toward us. Not because it has chosen us. not because galaxies aim themselves with intention, but because gravity is slowly drawing the Milky Way and Andromeda together. In several billion years, the two galaxies may begin to merge, not collide like solid objects, not crash like cars on a highway. Galaxies are mostly empty space. Their stars are separated by such huge distances that direct star-to-star collisions would be rare. Instead, their gravity will reshape everything. Stars will be pulled into new orbits. Gas clouds may collide and ignite waves of new star formation. The familiar spiral shapes of both galaxies may slowly dissolve into something larger, older, and more chaotic. The night sky, if Earth still has a night sky then, would be transformed. Andromeda would grow brighter, larger, closer. Its stars and dust would spread across the darkness. The Milky Way would no longer be alone in the sky. But that future is billions of years away. It belongs to a time so distant that the sun itself will be different. Earth may no longer be the world we know. The oceans may be gone. The continents may be unrecognizable. Life, if it remains, may be nothing like us. The merger of the Milky Way and Andromeda is not a human event. It is a galactic event. It belongs to a clock too large for civilization, and that gives Andromeda its strange emotional power. It is both coming toward us and unreachable. It is both a future neighbor and an ancient image. It is close enough to be seen, but too far away to know as it is. It reminds us that the universe can make something visible without making it available. A galaxy can send its light into your eye while keeping its present millions of years away. It can be part of your night and still remain outside your time. This is why Andromeda feels different from Proxima. Proxima is the nearest impossible star. Andromeda is the nearest impossible galaxy. One is a red ember hidden from the naked eye. The other is a trillion-star system, faint enough to look like a breath on glass. Both are real. Both are near by cosmic standards. Both are beyond reach. And somewhere inside Andromeda, there may be planets. There may be oceans. There may be moons circling gas giants. There may be skies with 2 or 3 bright stars at dusk. There may be landscapes under suns that formed before our sun was born. There may be histories no telescope will ever resolve. All of it is packed inside that faint oval glow. All of it is arriving as ancient light. When you look at Andromeda, you are not only looking across space. You are looking across a gap so old that Earth itself was a different planet when the journey began. And still, the light arrives gently, without sound, without force, without asking to be understood. It simply reaches us, after 2.5 million years, and gives the human eye one quiet glimpse of another island of stars. If Andromeda's light can enter the human eye while its present remains millions of years away, what does it really mean to see another galaxy? After Andromeda, distance begins to feel almost impossible. A galaxy close enough for the human eye is still millions of years away by light. A neighbor becomes ancient. A smudge in the sky becomes a message from before our species had entered the world. But beyond Andromeda, the universe opens again. The distances grow larger. The light grows older. And eventually, looking across space no longer means looking at galaxies as they are. It means looking at the universe when it was young. This is where the James Webb Space Telescope enters the story. Not as a machine that defeats distance. Not as a telescope that brings the universe close. But as an instrument sensitive enough to receive light that has been weakened, stretched, and changed by nearly the entire history of the cosmos. Webb does not remove the distance. It listens through it. It waits for ancient photons to arrive. It studies light that began its journey before the sun existed, before Earth existed, before there were oceans here, before there was a sky on this planet for anyone to look through. In that sense, Webb is not only a telescope, it is a reader of deep time. To understand why Webb matters, we have to remember what expansion does to light. As the universe expands, the space between galaxies stretches, and as space stretches, the light moving through it stretches too. A galaxy may have emitted bright visible or ultraviolet light billions of years ago, but by the time that light reaches us, its wavelengths have been pulled longer and longer. The light shifts toward red, then beyond red, into infrared, into a kind of light human eyes cannot see. This is why Webb was built to observe infrared light. It was made to see the kind of ancient light that the expanding universe has carried into invisibility. Hubble showed us deep space in ways that changed the human imagination. It revealed galaxies where the sky looked empty. It turned darkness into history. But Webb was designed to look deeper into the cooled and stretched light of the early universe. It was designed to search for the first galaxies, the first stars, the first black holes, the earliest structures that rose from a universe that had once been hot, dense, and nearly featureless. And what Webb has found is not simple. The early universe was expected to be strange. It was expected to be raw. It was expected to be filled with small beginnings, young stars, small galaxies, early clumps of matter slowly gathering themselves into the larger structures we see today. But Webb has shown us galaxies that appear surprisingly bright, surprisingly organized, surprisingly active at times, when the universe was only a few 100 million years old. It has found light from objects that existed when the cosmos was still in its childhood, not in the middle of its life, not after billions of years of slow construction, but near the cosmic dawn, when the first generations of stars were beginning to change the dark. One of the most distant galaxies confirmed by Webb, MOM Z14, appears as it was only about 280 million years after the Big Bang. That is difficult to feel. 280 million years sounds long on Earth. It is longer than the age of mammals, longer than the age of flowering plants, longer than the rise and fall of countless species. But for the universe, it is early morning. The cosmos today is about 13.8 billion years old. So a galaxy from 280 million years after the beginning is not an old galaxy in an old universe. It is a young structure in a universe still learning how to become transparent, luminous, and complex. The light from that galaxy has been traveling for more than 13 billion years. It crossed a universe that was changing the entire time. It moved through expanding space. It passed through ages before the Milky Way took its familiar form. It was already on its way when the atoms that would one day become Earth were scattered in older generations of stars. And now, after nearly everything we call cosmic history, it arrives at a mirror floating far from Earth. That is what Webb catches. Not a nearby image, not a present moment, a surviving message from the beginning. There are other strange signals too. Webb has seen a galaxy called Jade's GS-Z13-1 from about 330 million years after the Big Bang. That galaxy shows strong hydrogen emission from an era when the universe should still have been filled with a thick fog of neutral hydrogen. In the early universe, light did not always travel freely the way it does now. There was a long transition when the first stars and galaxies began to burn away that cosmic fog. This period is called reionization. It is one of the great changes in cosmic history. Before it, much of the universe was harder for light to cross. After it, space became more transparent. The first galaxies were not only lighting the dark, they were changing the dark so that light could move through it. And Webb is showing that this process may have been patchy, uneven, and surprising. Some galaxies may have cleared paths through the fog earlier than expected. Some may have formed hot young stars powerful enough to carve out transparent regions around them. Some may have had black holes at their centers, helping energy pour into the young universe. The farther Webb looks, the more the beginning seems alive with activity. Not calm, not slow, not simple. The young universe may have been building faster than we thought. This does not mean the universe is broken. It does not mean the Big Bang is wrong. It does not mean every model must be thrown away. The better truth is quieter and more interesting. Webb is showing us that the early universe had details we did not fully understand. It may have made bright galaxies faster. It may have formed massive stars in unusual ways. It may have grown black holes earlier than expected. It may have turned simple beginnings into structure with surprising efficiency. Science often advances this way, not by replacing wonder with certainty, but by making the mystery sharper. Before Webb, the first galaxies were partly hidden behind distance, redshift, and the limits of older instruments. Now some of them are beginning to appear. Faint, red, tiny, stretched by cosmic expansion, but real. And each one tells us that the universe was already becoming something. Already forming stars, already gathering gas, already producing heavy elements. Already making the first steps toward the galaxies, planets, and chemistry that would eventually make observers possible. There is something deeply strange about that. When Webb looks at a galaxy from cosmic dawn, it is not only studying an object far away. It is studying an ancestor of everything. The stars in those early galaxies helped change the chemical story of the universe. The first generations of stars forged heavier elements. They exploded. They seeded space. They made future stars and planets possible. Long before Earth existed, the materials that would one day allow rocky worlds and living cells had to be cooked inside stars and scattered into space. So when Webb looks backward, it is not looking at a separate universe. It is looking at the early chapters of our own. The distance is enormous, but the connection is real. The carbon in a body, the oxygen in a breath, the iron in blood, the silicon in stone. All of it belongs to a long chain of cosmic events that began before there was a planet here to receive the light. This is why Webb feels different from a telescope pointed only outward. It points outward and backward at the same time. It shows us that distance is not only separation. Distance is memory. A galaxy 13 billion light-years away is unreachable, but its light is not meaningless. It carries information about how the universe learned to make structure. It carries signs of stars that lived and died before the sun was born. It carries chemical fingerprints. It carries clues about the first black holes. It carries traces of an age that no spacecraft could ever visit. And still, there are limits. Webb can see far, but not everything. There are times before the first stars when there was no starlight to collect. There are regions whose light has not reached us. There are signals stretched so faint that even our best instruments may never recover them. There are questions hidden behind the first darkness, before galaxies, before stars, before the universe became transparent enough to send us a picture of itself. Webb has opened a window. But a window is not the whole sky. It gives us a view. It does not end the mystery. Somewhere beyond its deepest images, the first stars burned in darkness we are still trying to understand. Somewhere in the early universe, black holes may have formed from collapsing gas, or from the deaths of enormous stars, or by pathways we have not yet fully imagined. Somewhere in that young cosmic fog, the first galaxies began to clear space for light. And the light that escaped has been traveling ever since, across billions of years, across expanding space. across the birth of galaxies, across the formation of the Milky Way, across the birth of the Sun, across the cooling of Earth, across oceans, continents, life, extinction, memory, and human history, until finally it arrives. A faint infrared whisper at the edge of detection, a message from the universe when the universe was young. And if Webb is only now receiving light from the first galaxies, how much of the universe's childhood is still hidden beyond the darkness? After Webb, the universe begins to feel almost bottomless. We have followed light from the Moon, from Mars, from Voyager, from the nearest star, from the Milky Way, from Andromeda, and from galaxies born near the cosmic dawn. Each step has carried us farther away. Each step has also carried us farther back in time. But there is one more scale that changes the meaning of distance completely: the observable universe. That phrase sounds simple. It sounds like it means the universe we can see. And in one sense, it does. But it does not mean the whole universe. It does not mean the edge of everything. It does not mean there is a wall somewhere, or a final border where space suddenly stops. The observable universe is only the region from which light has had enough time to reach us. It is not the end of reality. It is the end of arriving information. This is one of the hardest ideas to feel, because the word observable makes the universe sound smaller than it is. It gives us a sphere around Earth, with us at the center, and distant galaxies fading toward the edge. But we are not at the center of the universe. We are only at the center of what we can observe. Every observer anywhere in the cosmos would have their own observable universe around them. A galaxy billions of light years away would see a different sky. It would have a different horizon. Some regions visible to us would be invisible to them. Some regions visible to them would be forever beyond us. The horizon depends on where you are. It is not a place in space. It is a boundary made by time, light, and expansion. The universe is about 13.8 billion years old. At first, that might make the observable universe sound as if it should be about 27.6 billion light-years across. 13.8 billion light-years in one direction, 13.8 billion in the other. But the real number is much larger. The observable universe is about 93 billion light-years across. That number feels impossible at first. How can we see something that is now more than 13.8 billion light-years away if the universe is only 13.8 billion years old? The answer is expansion. The light did not travel through a still universe. It traveled through space, while space itself was growing. When the most distant light we can see began its journey, the source was much closer than it is now. As the light crossed the cosmos, the space between that source and us kept stretching. The light moved toward us, but the distance it crossed was changing beneath it. By the time it finally arrived, the region that released it had been carried far away by the expansion of the universe. So the farthest things we can observe are not just far. They are far in a moving, growing universe. Their light tells us where they were. Cosmology tells us how far away those regions are now. And those two ideas are not the same. This is why the observable universe feels so strange. It is not a simple bubble drawn around Earth. It is a record of light that has survived a changing universe. It is a sphere of old messages, stretched and reddened by time. It contains galaxies at many different ages. Nearby galaxies appear as they were recently. Distant galaxies appear as they were billions of years ago. The deepest galaxies appear as they were when the universe was young. The sky is not arranged by distance alone. It is arranged by age. Looking outward is like looking through a stack of cosmic memories. The farther the layer, the older the memory. And somewhere near the deepest layer, we reach the oldest light we can see, the cosmic microwave background. This is not starlight. It is not light from galaxies. It is the afterglow of the early universe, released when the cosmos had cooled enough for light to travel freely. Before that moment, the universe was like a fog. Photons could not move far without scattering. There was no clear view. Then the fog lifted. Light escaped, and that ancient light has been traveling ever since. Today it reaches us not as visible light, but as microwave radiation, stretched by the expansion of the universe for billions of years. It comes from every direction, a faint glow behind all galaxies, a baby picture of the cosmos. But even this ancient glow is not the beginning itself. It comes from a time about 380,000 years after the Big Bang. That is early, but not the first moment. Before it lies an era hidden from ordinary telescopes, a time before light could travel freely, a time when the universe was too hot, too dense, too opaque to send us the kind of image we understand. So even the oldest light is not the first page. It is only the earliest page light has been able to carry to us. And beyond the observable universe, there may be much more. Maybe the universe continues far beyond our horizon. Maybe it is so large that our visible region is only a tiny patch. Maybe it is infinite. Maybe there are galaxies whose light has not had enough time to arrive. Maybe there are regions so distant that their light never will. We do not know the total size of the universe. We know the size of our window. That difference matters. A window can show a landscape. It cannot prove the landscape ends where the glass ends. The observable universe is like that. It is a window made of time. Everything inside it has managed, in some form, to send information to us. Everything outside it remains beyond the reach of our sky, not necessarily non-existent, not necessarily empty, only unreceived, only beyond the part of reality that has had time to speak to us. This is a quieter kind of fear than the distance to Proxima. Proxima is unreachable by our machines. Andromeda is unreachable by our civilization. But the cosmic horizon is deeper. It is not only about where we cannot go. It is about what we may never know. There may be structures beyond it. More galaxies. More clusters. More voids. More histories. More places where stars were born, planets formed, and perhaps life looked up beneath a sky we will never see. Those places may be real. They may be part of the same universe. But if their light never reaches us, they will never become evidence. They will never become an image. They will never become a point in our maps. They will remain outside the story the universe is able to tell from here. And this changes what it means to understand the cosmos. Science is often described as a search for truth. But in cosmology, truth arrives at the speed of light. Truth must cross distance. Truth can be delayed. Truth can be stretched. Truth can be hidden behind horizons that no telescope can pass. We do not study the universe from above. We study it from inside. From one planet, around one star, in one galaxy, at one moment in cosmic time. And from here, we build a picture of everything we can reach with light. It is an astonishing achievement, but it is also a reminder. The observable universe is not the universe obeying our curiosity. It is the universe giving us only what has arrived. We are surrounded by a sphere of ancient light. Beyond it, there may be more reality than we can ever turn into knowledge. No wall, no edge, no final border glowing in the dark. Only a horizon, only the place where the messages stop. And if the edge of the observable universe is only the edge of arriving light, what lies beyond the part of reality that has had time to reach us? Beyond the observable universe, the mystery becomes quiet. Not quiet because nothing is happening. Quiet because the scale has moved beyond anything a human life can interrupt. The universe is not only large, it is changing. It is expanding. The space between distant galaxies is growing, slowly on smaller scales, but powerfully across the deepest distances. This expansion does not mean galaxies are flying through space like sparks from an explosion. It means space itself is stretching. The distance between galaxy clusters grows because the fabric between them grows. On the scale of stars, planets, solar systems, and even galaxies, gravity is strong enough to hold things together. The Earth does not expand away from the Sun. The Moon does not expand away from Earth because of cosmic expansion. The Milky Way does not stretch apart like a balloon. Local gravity keeps local things bound. But far beyond the local group, beyond galaxies tied together by gravity, the expansion of the universe becomes the larger rule. Distant galaxies recede. Their light is stretched. Their colors shift toward red. The farther away they are, the more the expansion has changed the light by the time it reaches us. For much of the 20th century, astronomers expected this expansion to slow down. That seemed natural. Gravity pulls. Matter attracts matter. If the universe began expanding long ago, then all the matter inside it should have been pulling back against that expansion, slowing it over time. But the universe did something stranger. In the late 1990s, scientists studying distant exploding stars found that the expansion was not slowing down. It was speeding up. The most distant supernovae were dimmer than expected. They were farther away than they should have been in a universe whose expansion was decelerating. Something was pushing the universe apart. Something was causing expansion to accelerate. We call it dark energy. That name sounds like an answer. It is not really an answer. It is a label for a mystery. Dark energy appears to make up most of the energy content of the universe. It acts on the largest scales. It does not build stars. It does not shine. It does not gather into planets or galaxies, but it shapes the long future of everything. It pushes the distant universe away from itself. And this is where distance becomes more than a challenge. It becomes a loss. There are galaxies so far away that space between us and them is expanding faster than their light can overcome. This does not mean those galaxies are breaking the speed limit by moving through space faster than light. Nothing local is doing that. Instead, space itself is expanding between us and them. The light they emit today may never reach us. It may begin the journey. It may travel at the fastest speed the universe allows. But the road beneath it is stretching too quickly. The light moves, the distance grows, and the message never arrives. This is one of the most haunting ideas in cosmology. There are places in the universe that may exist right now, filled with stars, planets, dust, and histories, whose present light will never become part of our future sky. They are not imaginary. They are not necessarily gone. They are not destroyed. They are simply leaving in the deepest possible sense. Not moving away like a ship on the ocean. Not fading behind a mountain. Leaving because the universe itself is making more space between here and there. A galaxy can become unreachable, not because it is too dangerous, too hidden, or too far for our machines. It can become unreachable because no signal sent today can ever cross the growing distance. This separates two ideas that often feel the same: what we can see and what we can reach. The observable universe is already larger than the reachable universe. We can see ancient light from galaxies that are now far beyond any journey or message we could send. They are visible as they were. They are not available as they are. The universe shows us more than it allows us to touch. It gives us images from places that have already slipped beyond contact. In the far future, this separation becomes even more severe. If dark energy continues behaving the way it appears to behave now, more and more distant galaxies will fade beyond the cosmic event horizon. their light will stretch to longer wavelengths. Visible light will become infrared. Infrared will become microwaves. Microwaves will become radio waves. The signal will weaken. The image will dim. Eventually, whole galaxies will vanish from view, not because their stars went out, but because expansion carried their light beyond recovery. The night sky of the far future will be much emptier. A civilization living then, if any exists, may look out and see only the galaxies gravitationally bound to its own local region. The rest of the cosmic web may be gone from evidence. The great clusters, the distant filaments, the ancient structure of the universe, all of it may have faded beyond the horizon. Such observers might not know the universe was once filled with visible galaxies in every direction. They might not know about cosmic expansion in the same way. They might not be able to reconstruct the full history we can see now. They would live in a darker, more isolated cosmos, not because the universe had become smaller, but because the reachable light had become less. That makes our moment feel strangely precious. We live at a time when the universe is old enough to contain planets, stars, galaxies, heavy elements, life, and observers. But it is also young enough that the distant universe has not completely disappeared. The window is still open. Ancient light is still arriving. The cosmic microwave background still surrounds us. The deep galaxies are still visible. The web of large-scale structure can still be mapped. The universe is still telling us its story. But it will not tell that story forever in the same way. There is a sadness in that. A quiet kind of cosmic sunset. Not the end of stars. Not the end of galaxies. But the fading of connection. The slow loss of distant information. The gradual retreat of everything not held close by gravity. And this is why space distance is scarier than a simple number. It is not just that the universe is hard to cross. It is that parts of it are becoming impossible even to know. There are regions whose old light has reached us, while their new light never will. There are galaxies we can study as ancient ghosts, but never as present worlds. There are places already turning into silence. And the silence is not empty. It is full of things that cannot answer. Dark energy turns the future of the universe into a narrowing window. For now, we stand inside the window, while it is still wide enough to see billions of galaxies. We receive light that left before Earth existed. We study structures larger than imagination. We map a universe that future observers may never be able to prove was there. That may be one of the deepest gifts of living now. Not that we can reach the universe, but that the universe has not yet fully disappeared from view. And if a galaxy truly exists, but no future light from it can ever reach us, is it still part of our universe in any meaningful way? After all of this, we return to Earth. Not because the journey is over. Not because the universe has become smaller, but because every cosmic journey, no matter how far it travels, begins and ends from here. A small, rocky planet. A blue and white world orbiting an ordinary star. A place with oceans, clouds, forests, deserts, cities, highways, bedrooms, fields, and quiet backyards where someone can step outside at night and look up. From the surface, Earth can feel large. A continent can feel endless. An ocean can feel impossible to cross. A mountain range can feel like a wall built by the planet itself. Even a long drive across the United States can make the world feel enormous. Hour after hour. State after state. The road changing beneath the tires. The sky changing color through the windshield. The body understands that kind of distance. It can feel miles. It can feel weather. It can feel fatigue. But the universe asks the mind to leave all of that behind. It asks us to imagine distances that do not fit inside a life. It asks us to imagine light traveling for years, then thousands of years, then millions, then billions. It asks us to understand that the stars above us are not arranged in one present moment. They are a slow reign of different ages. The moon is a little more than a second away by light. The sun is more than 8 minutes away. Mars may be many minutes away, depending on where it is in its orbit. Voyager is many hours away. Proxima Centauri is more than 4 years away. The center of the Milky Way is tens of thousands of years away. Andromeda is 2.5 million years away. The oldest galaxies seen by Webb are more than 13 billion years away in light travel time. And still, all of that light arrives here, to this planet, to this atmosphere, to mirrors and antennas and instruments built by a species that has never physically traveled beyond the moon. That may be the most astonishing part, not only that the universe is so large, but that we have learned how to measure it. We are small, but not blind. We are limited, but not silent. We cannot cross the Milky Way, but we can map its shape. We cannot reach Andromeda, but we can know its distance. We cannot visit the first galaxies, but Webb can catch their ancient light. We cannot step outside the observable universe, but we can understand why the horizon exists. There is humility in that, and there is beauty, because knowledge does not always require possession. To understand something is not the same as owning it. To see something is not the same as reaching it. The universe gives us almost nothing by touch, but it gives us light. Old light, faint light, red-shifted light, light stretched almost beyond recognition, light that has crossed emptiness so wide that the journey itself becomes part of the message. Every photon that reaches Earth has survived a path through space and time. Some left a star before a human language was spoken. Some left a galaxy before Earth had life. Some began their journey before the sun was born. And now they arrive. Not loudly, not with ceremony. They fall into telescopes. They strike detectors. They enter human eyes on dark nights. They become data. They become images. They become questions. They become wonder. That is what our planet receives. Not the universe itself, only its arriving messages. And from those messages, we build a story. A story of stars forming from clouds of hydrogen. A story of galaxies gathering along invisible dark matter threads. A story of black holes growing in the centers of galaxies. A story of heavy elements forged inside stars and scattered by explosions. A story of one ordinary star forming in one ordinary galaxy. A story of dust becoming rock. Rock becoming planet. Planet becoming ocean. Ocean becoming life. Life becoming memory. Memory becoming a mind that could look back into the dark and ask where it came from. There is something quietly circular in that. The universe made the atoms that made Earth. Earth made the conditions that made life. Life made minds. And minds made telescopes. Then the telescopes looked back into the universe and found the ancient light from which the story began. We are not outside the cosmos, studying it from a safe distance. We are part of the thing we are trying to understand. We are matter that learned to measure matter. We are stardust asking how far the stars go. And maybe that is why cosmic distance feels so emotional. It makes us small, but it also connects us to everything. It shows us that we are not central, but we are included. We are not the reason the universe exists. But we are one of the ways the universe has become aware of its own size. That does not make the distances easier. The nearest star is still almost impossibly far. The galaxy is still too large for conversation. Andromeda is still ancient by the time its light arrives. The observable universe is still only a horizon. Dark energy is still carrying distant regions away from us. Most of the universe will never be touched by human hands. Most of it will never answer us. Most of it will remain image, inference, signal, silence. But perhaps that is why each piece of arriving light matters more. Each star we see is not just a point. It is a successful crossing. Each galaxy in a deep field image is not just a smudge. It is a message that traveled through expanding space and survived long enough to be caught. Each measurement is a small victory against distance, not a conquest. Not an escape, a listening, a patient act of attention. This is the kind of knowledge suited to a small planet. We do not command the cosmos. We receive it. We wait for it. We build instruments delicate enough to notice what the darkness sends. And then we try, with our brief lives and fragile languages, to understand what has arrived. Somewhere tonight, someone may step outside and look up without thinking about any of this. They may see a few stars above a neighborhood street. They may hear cars in the distance. They may feel the air cooling after sunset. They may see only a quiet sky. But above them, the universe is pouring down ancient time. Light from different years, different centuries, different eras, different worlds, all crossing the final few miles of atmosphere and arriving together as night. The sky is not empty. It is not still. It is not close. It is a layered memory of everything that was able to send us light. And Earth is the small island where, for now, some of that light comes ashore. Here, on this small world, we wake beneath a nearby star. We sleep beneath distant ones. We build our lives inside a thin shell of air, surrounded by a universe too wide to cross, too old to fully imagine, and too mysterious to ever become ordinary. And still, the light keeps arriving. From the moon, from the sun, from Mars, from Voyager, from Proxima, from the Milky Way, from Andromeda, from the first galaxies, from the edge of what can be known. It arrives quietly. It arrives late. It arrives carrying pieces of a universe we may never reach, but can still, for a little while, behold. And if Earth is only a small island of arriving light, what ancient messages are still crossing the dark, not yet here, not yet known, still on their way? So let the journey slow down now. Let the numbers fade a little. Let the galaxies drift back into the dark. Let the great distances become quiet again. We have crossed the moon by light. We have waited for sunlight to arrive. We have followed signals to Mars. We have moved past Jupiter, Saturn, Neptune, and the frozen outer dark of the solar system. We have watched Voyager continue its long goodbye. We have stood in imagination beneath the faint red glow of Proxima Centauri. We have stepped back until the Milky Way became not a sky, but a galaxy. We have seen Andromeda as ancient light. We have listened with Webb to the young universe. We have reached the horizon of what light has had time to tell us. And we have watched dark energy carry distant places away, not with violence, but with silence. All of it leads back to one simple truth. Space is not just large. It is patient. It does not hurry to reveal itself. It sends light across years, across ages, across the rise and fall of worlds. And we receive it only when it arrives. Not before, not by force, not because we ask. Only when the universe has allowed the message to cross the dark. Maybe that is why the night sky feels so calm. It is not calm because nothing is happening. It is calm because everything is happening on scales too large for panic. Stars are forming. Stars are dying. Galaxies are merging. Black holes are growing. Light is crossing the emptiness between worlds. But from here, beneath the atmosphere of Earth, it arrives as stillness. A soft point of light. A faint glow. A quiet sky. The universe is moving, But it does not rush us. It lets us look. It lets us wonder. It lets us fall asleep beneath distances we may never cross. And perhaps that is enough for tonight. Not to solve every mystery, not to reach every star, not to understand everything hidden beyond the horizon, but simply to rest inside the knowledge that we are here, on a small planet, in a thin atmosphere, beside an ordinary star, surrounded by ancient light, still finding its way home. Somewhere far beyond us, new photons are beginning their journey. Some have just left a distant galaxy. Some have just escaped the surface of a star. Some have crossed a cosmic void for millions of years and still have millions more to go. Some will arrive long after we are gone. Some may never arrive at all. And still, the universe continues, quietly, patiently, immensely. So when you next look up at the night sky, remember that you are not looking at empty darkness. You are looking into distance. You are looking into time. You are looking into a universe that is still sending itself toward you, one photon at a time. And somewhere in that darkness, beyond the reach of every road, every rocket, and every dream of speed, there may still be light on its way. Good night. And what will the sky reveal when the next ancient message finally arrives?